welcome to STEM, and today we're gonna learn about a new topic in our chemistry class, and this is about acid and base. So firstly we're gonna learn about acid. So what is acid? It donates proton in aqueous water or other situations. It shows sour taste and it turns our litmus paper from blue to red. This is case for acid, and when acid reacts with a base, it forms water and salt. So according to Arrhenius, acid actually increases the proton H plus in water or aqueous anything, in case of aqueous media or liquid media. So bronze state, but in case of bronze state laundry, acid is a proton donor. So that's for acid. So acid has two parts, strong acid and weak acid. So how we can define the strong and weak acid? So firstly, a strong acid completely ionizes in water to produce hydrogen ion and hydronium ion. In water it produces H plus and H3O plus, those ion in case of strong acid. So how we gonna define those strong acid? First we need to know the properties how to identify a strong acid. Firstly, it shows high electron conductivity due to its 4 more free ions, as it produces hydrogen or hydronium ion in this aqueous solution. It gonna have more free ions to revolve around that, and because of this reason it shows high electron conductivity. So here for our first property. Secondly, it shows very low pH, as the H plus ion is high here, so it gonna show a low pH situation, typically 0 to 3, and our acidic situation here is that from start acid base situation, so from 0 to 14 and till 6, 0 to 6 it is gonna have acid part, and from 7 to 14 it gonna have base part, and that 0 to 6 have two part, strong acid and weak acid. In case of strong acid, from 0 to 3 it gonna have the strong part of acid. Highly acidic environment, we gonna see this pH. For the second part, very low pH, typically 0 to 3. And thirdly, it show high corrosive and reactive, as there is more free ions revolve around them, they shows more reactive situation around them, they easily react with others. That's why they show high corrosive and reactive environment. And lastly, for the strong acid, it strongly affects acid base indicators. We gonna know about indicators in next class, that here acid base indicators, in case of that part, they show highly reactions. And for example, we're going to HCl, H2SO4, HNO3, H hydrogen bromide, and those are the high acidic components. They have the pH between 0 to 3. So what happened here? Those have, we need to compare those here. Those have a high electron conductivity into them. They are typically pH from 0 to 3. They are highly reactive. When they are with other compounds, they're gonna show more high reaction. If we combine HCl with some other thing, we're gonna see something new compound, but those reaction gonna happen easily because those electrons, there are more proton around them which gonna react with them. That's for strong acid. Now we're gonna learn about the weak acid part. It partially ionizes in water, not completely but partially it ionizes its water, and this is the part differ from the strong acid, which differ the weak acid here, partially and here completely. So ionizes in water on a small fraction of the acid molecules releases H plus ion, and here H plus ion and hydronium ion both shows both component releases. And for the properties, it show low electrical conductivity, as there is not much of electron going on around, but it does releases high high amount of H plus ion, but it is comparatively lower than strong acid, so it shows low electrical conductivity. And it does have a high pH than strong acid. It is relatively more closer to base. Here from 3 to 6, it is almost like a base compound but not base. So here it shows less corrosive, but here in case of here we see high corrosive and reactivity, but they relatively react more less than strong acid. And weak effect on indicator, and they shows weak effect on acid base indicator in case of weak acid, and those are the weak acid compounds CH3COOH. They easily combine with base and show reactions CH3COOH, HCOH, and those hydrocarbonate. Those are for the weak acid. And next we're gonna learn about base. We're gonna talk about the base. Here it shows that it accepts a proton or donut electron pair in an aqueous environment, and it releases hydroxide ion in an aqueous environment. So mostly that thing has happened, you know, NaOH plus, this is the reaction here, NaOH, it produce Na plus and OH minus. Those OH minus gonna increase in the aqueous environment, and it gonna give it a base environment, and it has a bitter taste or a slippery taste. And most important part, that in litmus paper it show red to blue color changes here in those points. So in case of Arrhenius law, it increases OH minus concentration in aqueous environment, and in a Bronsted-Lowry law, it is a proton acceptor. So this is for the base information, and for the base it has two parts, strong base and weak bases. So in case of strong bases, it dissociates in water to give us a hydroxide ion and hydroxide ion environment. So in what here we see, so the reaction sodium hydroxide, it's gonna produce OH minus, and it's gonna increase the number here in the aqueous environments. So for the properties, how we gonna define between the strong bases and weak bases, and we're gonna compare it with acid. So through those properties we're gonna know about it. So firstly, it has high pHs, pH 11 to 14, and it shows strong electrolytes components in case of bases, strong electrolytes, and they are highly corrosive and caustic, and they easily react in the aqueous environment and produce OH minus, and they are rapidly neutralized in acid components. So here the example for sodium hydroxide, potassium hydroxide, calcium hydroxide, those are the things we're gonna know, that those hydroxide OH, through those components we're gonna identify a base. So this for the strong base, and now we're gonna know about the weak bases. Partially, here also we see the partially word. Here partially, but in case of strong base, it gonna completely dissociates in water, but in that case it gonna partially dissociates in water, and because of it gonna produce a small number of OH minus, and here we gonna get a larger amount of OH minus in strong base. So for the properties, it should lower pH than strong bases. In strong bases, we see the 11 to 14 for the pH number, high pH, and here we see the 8 to 11 for the weak bases. And they are weak electrolytes, and here strong bases are strong electrolytes. We gonna use those you can use those information as the differentiation. If we learn it through differentiation, it gonna easily memorable. So they are mildly basic and less reactive, and less reactive, here we're gonna see that high corrosive and caustic, and their reaction rates are more than weak bases in case of strong bases. And they are incomplete, they have incomplete neutralization, but they are rapidly neutralized in case of water, acid, and those are the example for weak bases, and here are the example for strong bases, and these are acid and base. Thank you everyone.